Right, we've got a worked example here in the coordinate systems section of further maths, and this one is to do with a hyperbola. So let's have a look. Hyperbola H has equation x squared over a squared minus y squared over b squared equals 1, a and b being constants. So this is a kind of a general the general form of a set of curves. The line L has equation y equals mx plus c, where m and c are constants. So we know there's a hyperbola and we know there's a straight line, but we don't really know what they are, do we? Because of all these unknown constants in. Given that L and H meet, show that the coordinates of the points of intersection are the roots of this equation. Let's see here. We've got this is a quadratic equation here. So this is the equation of intersection of these two lines, which are both in their general form. No wonder we've got so many constants in here. Okay, so let's have a look. I've just realized on this whole problem without actually doing any sort of diagram. Um, but since we don't know very much, it's not the easiest thing to draw, really. So the equation of intersection, basically what we're doing is we're taking our mx plus c and substituting it into there. And we get this. And from there on, basically, it's just a bit of horrible reorganization. Lots of stuff, not too bad actually. And there we got this. We've got this quadratic here. Here, this is the coefficient of x squared. This is the coefficient of x, and this is your constant. It's in quadratic form equals 0. Okay, so that's that. Hence, given that L is a tangent to H, show that a squared m squared equals b squared plus c squared. Okay, let's go down here. All right, so since L is a tangent, then this equation of intersection is going to have a discriminant of 0. We've seen this a lot when we're dealing with simpler curves like circles and quadratics. Here we've got it with a hyperbola, but the principle is just the same. So since L is tangent, then the discriminant of this equation of intersection equals 0. So here we go. So this is the discriminant equation drawn from these coefficients. So here is our b squared. Here is our a squared. Well, here is our a. Here's our a. Here's our b, and here's our c. All right. So if we put that into a discriminant equation here, oh, I'm not going to talk through the next bit. You can pause the video and satisfy yourself that this is sort of coming out right. It's the most horrible piece of um, simplification you could imagine. But take it from me. Once you get to the end of it, basically we can show, therefore, that a squared m squared equals b squared plus c squared. So I think you might just have to work that through for yourself. Right. Now the third part. Now this really threw me, I have to say. I had to go away and think about this one. The hyperbola h dash has this equation. Find the equations of the tangents to h prime, which pass through the point 1, 4. Right. I mean, I can only just see this as attacking this as a new problem, but kind of if I just kind of walked away from the problem for a minute or two, and I realized that, of course, we have created this relationship. Basically, we got the equation in M and C here. And when we are talking about straight lines that pass through that point, we've got another equation with two unknowns in from y equals mx plus c. So let's just have a go at C, that part C now. So in this case, obviously we've got a value of a 5 and b of 4. So when we use that result in part B, it gives us this equation in M and C. And then, as I've just mentioned, the tangents required pass through this point. So if we're using the general form of the straight line and we substitute this point in there, we get this. So that second equation in C and M. So basically, if we just substitute this in for our C in there, we're going to get this and um, basically work that through. Well, it's a quadratic in M, isn't it now? So we're going to come right down to that, and that's going to give us our M values of 1 and minus 4 by 3. And then we can substitute those into probably that one and get our C values. So, and that gives us the those equations of the tangents, knowing the gradients and the intercept. So we can just write those like that. So, yeah, that's a tricky thing. I think that one of the learning points here, of course, is that, we've done all this work to do that. All right, this is a 7 marker, but you've got to think we're going to be leveraging that piece of work that we've done there to get this final bit, and so it is. So we don't have to start from scratch, differentiating and so on. Yeah, we've done the hard work doing that. So yeah, tricky problem. And well done to the examiner who created this problem. Obviously, seems to be the product of a bit of a weird mind, but hey, these are the problems we have to solve, and so I hope you have found that useful. And if you have any comments or anything's not clear, then leave those in the comments section, please. And I'll see you next time.